So welcome back. Let's continue with our lesson on soil, water and plant relationships by looking at what happens to the plant when you give it water. So there are a number of things which happen to the plant when you give it water. Firstly, as we said in the beginning, water is taken up by the plant and used by the plant in its metabolic processes. And because there is some kind of concentration gradient between the atmosphere and the plant, some water will be lost from the plants into the atmosphere through the stomachs. And some of the water which are applied on the soil, all of it may not be taken up by the plant. Some of it will be lost by evaporation, and some of it will be lost by depopulation. So there's a term which is called evapotranspiration, and it's a term which is very vital when it comes to irrigation and also irrigation planning. Evaporation, by the definition, is a diffusive process by which water from natural surfaces is lost in the form of vapor to the atmosphere. So the surfaces can be the surface of a leaf, or it can be from the soils. While transpiration is a process by which water is lost in the form of vapor through plant surfaces, particularly through the leaves, and we call the parts as stomata. If you combine the loss of water from the surfaces and also from the stomachs of the plants, the term is called evapotranspiration. So this figure depicts the process of evapotranspiration. As you can see, there is evaporation of water from the plants and also from the surface of the leaves and also from the stomachs, being powered by sun as a major heat provider. So moisture which is intercepted on the leaves, it's evaporated, and moisture which is available in the soil and basically within the top layer, as the previous lecture stated, is also lost into the atmosphere. That's why they say for shadowed crops and also for the shell swallows, you need frequent irrigation because it's highly hit by soil evaporation. And from the plants, there is a concentration gradient between the inside of the plant and also the outside, in which water is lost through the stomachs going outside into the atmosphere. There are several factors which affect evapotranspiration, which may be categorized into weather factors, crop factors, and also management factors. Under weather, you look at the air temperature, soil radiation, relative humidity, wind velocity, and rainfall. And when you want to describe the loss of water from the soil or from the plant, what you look at the concentration gradient between the two areas. An area where there is low moisture content, you expect that water will move from the higher moisture levels to the lower moisture levels. For example, if you look at wind velocity, when wind is blowing, it takes away with it soil moisture which was on the surface of the leaves, and because of that there is low concentration of water on the outside of the leaf than in the inside, which necessitates that water should move from inside the leaf going outside, a process called transpiration. Similarly, when you have a higher soil radiation and also higher temperatures, moisture which is available in the atmosphere gets evaporated, and this creates a concentration gradient between moisture available and also moisture inside the leaf. And because there is low concentration of moisture outside the leaf, water comes outside, comes from the leaf going outside. Also the process called transpiration, and when it reaches the surfaces, water is lost through evaporation. In higher rainfall periods, you expect higher evapotranspiration, higher evaporation, because water is readily available on the surfaces than outside the surface. So even with the small wind blows, small soil radiation, and also low air temperatures, moisture is still evaporated into the atmosphere during the rainfall seasons. If you look at the crop, you look at the stomata opening and also closing, stomata number and also size, canopy size, the adaptive mechanism of the crop, root depth and also proliferation and also length of the growing season. When a stom is closed, there is no transpiration from the leaves, and this will also affect the evapotranspiration. And when you have a lot of stomachs on the upper side, there is an increased transpiration, which also increase amount of water being evaporated into the atmosphere. That's why they say leaves are made in a mechanism that most stomachs are found on the lower side than on the upper side. The aim is to reduce the amount of water being evapotranspirated. The canopy cover, you are looking at the size of the leaf, the canopy. Leaves with the larger canopy cover transpire less than leaves with the small canopy cover. There are also other plants which have adaptive mechanism to control evapotranspiration, like the pointed leaves. Amakhala minga minga jonjo maleaves yake. The leaves which close when there is high temperatures. All these affect the amount of water being transpired and also being evaporated into the atmosphere. The rooting depth. Higher rooting depth means the crop may obtain water from higher levels, in which the water may be readily available in the crops, and all the stomachs may be open, which will increase a lot of water which can be evaporated. Similarly, if you have longer length of growing season, the last point, if the length is longer, there is also a longer period in which evaporation and transpiration can occur, and this will increase the amount of water being evaporated. And that's vice versa for the shorter growing season crops. That's why longer growing season crops, they need a lot of water during the season than the shorter period growing crops. In terms of management, you look at the irrigation method. There are some irrigation methods which have so many inefficiencies. For example, if you take surface irrigation system, most of the water is on open surface, and this increases high chances of evaporation of water into the atmosphere. Fertilization, a crop which grows healthy, automatically that crop is turgid. It has a lot of leaves, green leaves by the way, and all these will affect the amount of water being evaporated. A well-growing crop also evaporates a lot of water into the atmosphere than a crop which is less fertilized. Wind breaks. If you have an area where there are a lot of wind breaks, we said wind is a necessary factor which creates a concentration gradient between the conditions available on the atmosphere and the conditions in the plant. So if you have wind breaks, you are controlling the amount of water being evapotranspirated, similarly as antitranspirants. Salinity. Salinity is also a management factor. We said when soils are more saline, or when water is saline, the plant suffers drought conditions in which the plant leaf plant leaf, in which in the plant leaf the stom is closed and the plant shivers, and this will automatically control the amount of water being evapotranspirated. So all these factors affect evapotranspiration, and the climatic factors are summarized in this diagram. Higher soil radiation, low humidity, higher temperatures, and also higher wind will increase evapotranspiration, and the vice versa. Then there is a term which is called consumptive use. Consumptive use is a sum of losses due to evaporation plus transpiration from a crop field, as well as water being used by the plants to maintain its metabolic activities and also for building up plant tissues. We know that water which is taken up by the plant is not all water which is being transpired into the atmosphere, and not all water which is being evolved to the atmosphere. Some water is used to maintain the metabolic process of the plant, like the photosynthesis process, and also to build up some plant tissues within the plant. So actually the metabolic processes use a significant amount of water, which accounts for only 1% of the whole evapotranspiration losses. That's why when you want to calculate the amount of water being needed by a particular plant, the metabolic losses are not included. We just take the evapotranspiration losses because these are more than the amount of water which the crop really uses for its metabolic processes. So this consumptive use may be expressed as a daily consumptive use or a seasonal consumptive use. A daily consumptive use, you take amount of water being used within 24 hours period, and it's expressed in terms of millimeters per day. While the seasonal consumptive use, you take amount of water being used during the total growing season of the plant. If the plant takes 120 days, then you consider amount of water being used in 120 days. And this is expressed as in millimeters per season. Then we have the peak period consumptive use. Peak period consumptive use is the highest consumptive use period, usually between 6 to 10 days of the season. And when you are designing your irrigation system, you take into consideration the peak period consumptive use. So it's a period in which you have the highest ET nodes. We discussed during class about the difference of evapotranspiration. The highest ET nodes. In this period, there's a lot of water which is lost from the plant. And also, during the period which are very sensitive to the crop, during the flowering period, during the grain formation, it's a period in which the water will need a lot of water to build up its harvestable produce, where the canopy area is maximum and also capable of intercepting maximum photosynthesis active radiation and also atmospheric demand. So that's the peak period consumptive use. Now that we have understood what evapotranspiration is and also factors which affect evapotranspiration, you also need to understand what crop water requirements are. By understanding crop water requirements, there's one concept which is the reference crop evapotranspiration. The reference crop evapotranspiration expresses the evaporative demand of the atmosphere at a specific location and also time of the year, and does not consider the crop and the soil. Basically, you look at the amount of water which can be evaporated from the surface of a plant, or from the surface of a soil, or from the atmosphere. This amount of water will ultimately affect the amount of water which the crop needs. And when estimating evapotranspirations,